Hello everyone and welcome to the channel Chemistry without Cramming, a bowl of chemistry knowledge. My name is Agnes and I'm here to convince you that chemistry does not have to be difficult. I would like to help each of you, especially those for whom chemistry class is a weak point. The topic of this video is molarity of solutions, solving problems without using formulas. Okay, let's start. Guys, today will be a little different. There will be no formulas normally used in a chemistry class. It is not that these formulas are bad or incorrect. I just want to show you another way to solve these problems if, for example, you forget the formulas or simply don't learn them. So this video is for everyone who hates cramming formulas or is too lazy to learn them or has a short memory for patterns. However, if you want to hear some theory about today's topic or see the same problem solved based on formulas, I invite you to watch the previous video titled Molar Concentration of a Solution. Okay, in the introduction, I invite you to listen to today's lesson. Guys, short free reminders. Molar concentration equals the number of moles of solute divided by the volume of solution. The unit used for this concentration is mole over liter or mole per cubic decimeter. I would like to remind you that 1 liter equals 1000 milliliters equals 1 cubic decimeter equals 1000 cubic centimeters. Time for the problems. Problem number 1. Calculate the molar concentration of the solution knowing that 10 moles of the substance were dissolved in 5 liters of the solution. Let's start by writing down what we know and what we need to calculate in this problem. We know already the volume of the solution and number of moles of solute. We are looking for molarity of the solution. In 5 liters of the solution, there is 10 moles of solute. So 1 liter of solution contains X moles of solute. We calculate X by cross-multiplying this proportion, so 5 liters times X equals 1 liter times 10 moles. To solve for X, we need to divide both sides by 5 liters, so it follows that X equals 1 liter times 10 moles over 5 liters. You can see that the liters cancel out here and we get the result in moles. So X equals 2 moles of solute. Answer: the molar concentration, molarity of the solution equals 2 mole per liter. Now, problem number 2. In 4 liters of a solution, there is 14.9 grams of potassium chloride. Calculate the molar concentration of this solution. Let's start by writing down what we know and what we need to calculate in this problem. We know already the volume of the solution and weight of salt. We are looking for molarity of the solution. First point, we need to calculate the molar mass of potassium chloride. So molar mass of potassium chloride equals molar mass of potassium plus molar mass of chlorine equals 74.5 grams per mole. Now we know that each mole of potassium chloride weighs 74.5 grams. I will write down the molar mass of the potassium chloride data under the problem data for 2 reasons. First reason, I have limited space to present the next stages of solving the problem. Second reason, by writing it this way, we know clearly what information has been provided already and what still needs to be calculated. Second point, we need to convert the mass into the number of moles. 1 mole of potassium chloride weighed 74.5 grams. So X moles of potassium chloride weighed 14.9 grams. You can see that the grams cancel out here and we get the result in moles. So X equals 0.2 mole of potassium chloride. I write down the number of moles of the potassium chloride under the problem data. Finally, we are ready to calculate the molarity of the solution. In 4 liters of solution, there is 0.2 moles of potassium chloride. So 1 liter of solution contains X moles of potassium chloride. You can see that the liters cancel out here and we get the result in moles. So X equals 0.05 mole of potassium chloride. Therefore, we already had the answer to our problem. The molar concentration, molarity of this solution equals 0.05 mole per liter. If you like this video, please leave a thumbs up and subscribe to my channel to follow the next subjects. Please write a comment. What do you think about solving these problems without using formulas? And now, let's go to problem number 3. How many grams of sodium nitrate are in 250 grams cubic centimeters of a solution with a molar concentration 2 mole per liter? Let's start by writing down what we know and what we need to calculate in this problem. We know already the volume and molarity of the solution, and we are looking for weight of sodium nitrate. To convert cubic centimeters to liters, divide the numerical value of cubic centimeters by 1000. In other words, move the decimal point by 3 places. If you are not sure whether you should divide or multiply the value given in cubic centimeters, you can write down the proportion. 1 liter corresponds to 1000 cubic centimeters. Then X liters correspond to 250 cubic centimeters. So X equals 1 liter times 250 cubic centimeters divided by 1000 cubic centimeters. You can see that the cubic centimeters cancel out here and we get the result in liters. So 250 cubic centimeters equals 0.25 liter. Okay, let's get back to the problem. First step, we need to calculate the molar mass of sodium nitrate. We read the atomic mass of sodium, nitrogen, and oxygen from the periodic table and write them as a molar masses. So, molar mass of sodium nitrate equals molar mass of sodium plus molar mass of nitrogen plus molar mass of oxygen times 3 equals 85 grams per mole. Now we know that each mole of sodium nitrate weighs 85 grams. Let's write the molar mass of sodium nitrate under the data in the problem. Now we need to calculate the number of moles of sodium nitrate in the solution. 1 liter of the solution contains 2 moles of sodium nitrate. So 0.25 liter of the solution contains X moles of sodium nitrate. We calculate X by cross-multiplying this proportion, so 1 liter times X equals 0.25 liter times 2 moles. To solve for X, we need to divide both sides by 1 liter. So it follows that X equals 0.25 liter times 2 moles over 1 liter. You can see that the liters cancel out here and we get the result in moles. So X equals 0.5 moles of sodium nitrate. Let's write the number of moles of sodium nitrate under the data in the problem. Step 3. Now we convert the number of moles of sodium nitrate into the weight of the sample. 1 mole of sodium nitrate weighs 85 grams, So 0.5 mole of sodium nitrate weighs X grams. X equals 42.5 grams of solute. So now we have the answer to our problem. This solution contains 42.5 grams of sodium nitrate. Problem number 4. What volume of the calcium chloride solution with a molar concentration of 0.25 moles per liter contains 2.775 grams of calcium chloride? Let's start by writing down what we know and what we need to calculate in this problem. We know already the weight of salt and molarity of the solution, and we are looking for the volume of the solution. We need to calculate the molar mass of calcium chloride. We read the atomic mass of calcium and chlorine from the periodic table and write them as a molar masses. So, molar mass of calcium chloride equals molar mass of calcium plus molar mass of chlorine times 2 equals 111 grams per mole. Now we know that each mole of calcium chloride weighs 111 grams. Let's write the molar mass of calcium chloride under the data in the problem. Let's go to the second step. We calculate how much 0.25 mole of our salt weighs. 1 mole of calcium chloride weighs 111 grams. So 0.25 moles of calcium chloride weighs X grams. X equals 27.75 grams of calcium chloride. Let's write the mass of solute in 1 liter of solution under the data in the problem. In the step 3, finally, we calculate the volume of solution containing the mass calcium chloride indicated in the problem. In 1 liter of solution, there is 27.75 grams of solute. So in X liters, there is 2.775 grams of calcium chloride. Then X equals 1 liter times 2.775 grams divided by 27.75 grams. You can see that the grams cancel out here and we get the result in liters. So X equals 0.1 liter of calcium chloride. The answer for this problem is this volume equals 0.1 liter. Problem number 5. A student evaporated 100 milliliters of water from 300 milliliters of sodium hydroxide solution with a molar concentration of 0.5 mole per liter. Calculate the molar concentration of the resulting solution. Let's start by writing down what we know and what we need to calculate in this problem. We know already the volume of solution 1 and volume of evaporated water, and also we know the value of molarity of the solution 1. We are looking for the molarity of solution 2. Our data shows that we have to convert the volume from milliliters to liters. So 300 milliliters equals 0.3 liter and 100 milliliters equals 0.1 liter. Let's represent this with the help of the drawing. In the beginning, we have an initial solution with a volume of 0.3 liter and molarity 0.5 mole per liter. Then 0.1 liter of water is evaporated from this solution and we obtain a new final solution. The volume of the final solution is equal to the volume of the initial solution minus 0.1 liter, so minus the volume of evaporated water. In this problem, we need to calculate molarity of the final solution. In the first step, we calculate how many moles of sodium hydroxide are in 0.3 liter of the solution, so in the initial solution, and the same number of moles are in the final solution. Because our solution is zero point 0.5 molar, it means that 1 liter of the solution contains zero point 0.5 mole of solute. So 0.3 liter of solution contains X moles of sodium hydroxide. You can see that the liters cancel out here and we get the result in moles. So X equals 0.15 moles of sodium hydroxide. Let's represent this with the help of the drawing. In the initial solution, we have 0.15 moles of sodium hydroxide, and in the final solution, we have also same number of moles of sodium hydroxide. Why same? When we evaporate a solvent, in this case water, the number of moles of solute does not change. Now we are ready to calculate molarity of the final solution. 0.15 moles of sodium hydroxide there is in 0.2 liters of the solution. So X moles of solute there is in 1 liter of the solution. We see that the liters cancel out and we get the result in moles. Our 0.75 moles of sodium hydroxide is in the 1 liter of solution, so this is the value of molarity of the final solution. Answer to problem 5. Molar concentration of the final solution equals 0.75 mole per liter. Guys, that was the last problem from this subject. Finally, as usual, problems for those interested, titled Check Yourself. Answer to these problems you can find in the video description. Guys, that's all for today. Thank you very much for your attention. If you like this video, please leave a thumbs up and subscribe to my channel to follow the next subjects. I also invite you to leave comments. Thank you very much and see you in the next video.